Good morning everyone. Last time we have learned about phasor method and we have also learned how to see that simple harmonic motion is a component of uniform circular motion. Today we are going to consolidate those concepts and we are going to practice a few questions, right? So let's quickly revise what we have learned. It is that if we use some equation like, let's say, y equal to a sine omega t plus phi 0. Okay, this is SHM. Now if you want to represent this SHM either in form of uniform circular motion or as phasor, remember the concept is the same. So what to do? You draw a circle so that the radius of the circle is amplitude. Is that clear, everyone? Okay, further, if you are drawing phasor or if you are considering some particle moving around, then you see the idea is that if it's omega t plus phi 0, listen to this, if it's omega t plus phi 0, it means phasor or that particle p rotates anti-clockwise. That's confirmed. When it is omega t plus phi 0, it will rotate anti-clockwise because as time will pass, the angle should increase. The angle should increase. Right? Okay, and phi 0 obviously is telling you the initial angle, right? Initial phase. This whole thing is called phase and this is called initial phase. Correct? Okay? Hopefully you remember that. Again, A is the radius of this circle, or you can also say that A is the length of this phasor. Right? This phasor is going to rotate. Fine? Okay? Now, this is what you have if you want to express this in y coordinate form. But typically if you want to express it in x coordinate form, then instead of using sine, we can use cos. Is this clear? Instead of using sine, we could use cos. Alright? So, that depends on how you want to express it. Whether you want SHM on the y-axis or on the x-axis. Remember, trigonometry allows you to convert from one, that is cos to sine or sine to cos as required. Okay, we will talk about that also a little bit later. One more thing, one final thing which is fairly simple to understand. What is omega? Omega here serves two purposes. Number one, omega is the angular frequency for SHM. Is that clear? Omega here serves two purposes. Omega is the angular frequency for SHM. Right? Also if you recall what we have learned last time, we are saying that this particle is going around in a circle, it's doing UCM with a constant angular speed omega. So this omega here is both, right? What's the other one? Angular speed of phasor, or you could say angular speed of particle doing doing UCM. Be careful. Angular frequency for SHM. Okay, and angular speed for UCM. Is that clear? They are slightly different in the words here. So be careful with that. Don't mix them up. So what this tells you is how quickly this phasor rotates or how quickly this particle goes around the circle. Is it fine? The meanings are all clear? No problem. Let's solve or let's discuss examples. Suppose someone would say, can you draw this kind of diagram, phasor diagram, or can you draw this kind of circle for this particular motion? Let's say, okay, let's say we are asked or we are required to draw the phasor or this circle showing UCM for this kind of SHM. Let's say this is in centimeter, for example. So what we'll do is we will compare all the terms. So clearly amplitude is A and we are dealing with Y and sine, so that's good. Omega is 2 pi radian per second. Alright. Initial phase angle is pi by 4, that is like 45 degrees, of course. Okay. Right? So we have these things. Now using this and using this equation, we can make the circle or we can make the phasor. So first of all, amplitude of phasor or magnitude of phasor or the radius of the circle. How much should be the radius of the circle? 5 centimeters. Is that clear or not clear? Is that clear or not clear? 5 centimeters. Okay, very good. Then here we are dealing with y equal to sine. So that's okay. Like I said, if you want to use the phasor method, if you want to use this UCM component method, it's simpler if y is expressed in form of sine and x is expressed in form of cos. I repeat, it is simpler if y is expressed in form of sine and x in the form of cos. Right? That reason is due to components. So here everything is okay, no problem. So what is the initial phase? Pi by 4, 45 degrees. So let's say here, again angles are always measured anti-clockwise from the positive x-axis. Hopefully you all remember that. So this is initial phase pi by 4. Understood? So the particle that is doing UCM or the phasor, both, will start like this. Did you understand? It will start like this. And how will it rotate? It will rotate anti-clockwise. Clear? Alright? So, because we are dealing with y component, you can further say that as this particle P rotates on the circle, its y component here will go up and down, that is, it will oscillate. Hopefully you remember that as this goes around, this component will go up and down like that. It will oscillate. Is it fine? Okay? So that's it. This is how you draw or this is how you write down things. Now, what you can say is this P will come back to the same point after a time period, 2 pi by omega, of course, right? Because when one cycle is completed, right? So this would be 2 pi by 2 pi. That's 1 second. Of course, omega is 2 pi, so 2 pi by 2 pi, 1 second. That means after 1 second this is going to come back. Right? So time period of oscillation here is 1 second. Have you understood everything that I have related over here? Right. How do I know it will rotate anti-clockwise? This equation. As long as it is omega t plus phi 0. Okay, as long as it is omega t plus phi 0, what will happen is that as you increase time, suppose you put t equal to 0, then you put t equal to 1, then you put t equal to 2. Do you realize this angle, which is called phase angle? Right, this whole angle is called phase angle, right? So as time will pass, the phase will increase. Understood? As time will pass, the phase will increase. Phase will increase means this angle will increase gradually. Is it fine? So it will rotate anti-clockwise. Alright? Remember, trigonometry says that anti-clockwise angle is positive and clockwise angle is negative. Okay, let's try one more example of this kind. I hope everyone had noted this down. Okay, let's try this now. Suppose we want x equal to, let's say 10 centimeter into cos 4 pi t minus pi by 2. Okay, let's say it is given in this form. X equal to 10 centimeter into cos 4 pi t minus pi by 2. So let's start comparing. We will of course compare this with this kind of relation. Okay, right? So this is also anti-clockwise. Remember, why so? Simple idea again. As t will increase, this angle will increase, right? So that's why anti-clockwise. So one thing is clear, that this is going to turn anti-clockwise. Next, what are the constants? A, how much? 10 centimeter. Omega, 4 pi radian per second, and that means time period will be 2 pi by 4 pi, that is 1 by 2 second or half second, correct? What is initial phase? What is initial phase? What is initial phase? अरे એટલું બધું અઘરું છે કે બહુ ઈઝી લાગ્યું તો આન્સર ન લો. Initial phase is minus pi by 2, means minus 90 degree. So if we want to draw it, once again, here's the circle, right? This is origin, this side is positive x, okay, this side is positive x. So what's the initial phase? Minus 90 degree. So I should draw it here at the start. Is this fine? Or at the start the phasor will be here. Clear? What will be the length of this phasor? What will be the length of this phasor? Ten centimeter. Very good. So this is amplitude again. That is going to be 10 centimeter. Okay. We have taken anti-clockwise not because of this minus sign, everyone. This anti-clockwise, how do I know it's going to turn anti-clockwise? Simple idea. As time will increase, suppose you put time as 0, you get angle minus pi by 2. You put time as 1, you get angle 7 pi by 2. You put time as 2, you get 8 and then 16, 15 pi by 2. So like this is at t equal to 0, this is at t equal to 1, t equal to 2. So you see the angle is increasing. Right now the angle in initial case will be minus pi by 2. Gradually the angle will increase to 7 pi by 2, 15 pi by 2. So that means it is turning anti-clockwise. Okay? I repeated it, Mavi. Minus 90 is because of this. That minus and this anti-clockwise have nothing to do with each other. Simple idea, everyone. Suppose this is initial pi by 4. As this would turn anti-clockwise, do you realize angle will increase? Yes or no? So if I know that with time angle will increase, it will be turning anti-clockwise. If I know that with time angle will decrease, then it will be turning clockwise. Okay, yeah, of course we are going to do more examples, right? Don't worry about it. So here if I want to project it, then I am going to project it on x axis. Okay, so I am going to project it on x axis. So when this phasor is like this, or when the particle is here initially, where does the SHM start from? Remember, the SHM is on x axis here. So here is plus a, here is mean position 0, and here is the other end position minus a. So if particle is here, where will the SHM start from? Where will the SHM start from? Remember, we are looking at x component. X component. It will start from mean position. It will start from mean position. Where is the x component of this vector? Here, not there, 0. Did you understand? Everyone, the x component of this phasor that we have drawn. Phasor is a vector, rotating vector. Yeah, so where's the x component of this one? Here, 0. That means initially the particle doing SHM, is at mean position. I hope that is clear to you. You can also do it with a bit of math, if you don't want to get into all this. Have a look here. Put t equal to 0. Have a look here. Put t equal to 0. So 10 into cos minus pi by 2. What is cos minus 90 degree? Everyone, what is cos minus 90 degree? Zero. Very good. So do you see what I am saying? Again, this vector is here in initial position. Now it's going to rotate anti-clockwise. So if you take its x component, it's going to be 0, right? Because it's a vertical vector. So this is how equations can help you calculate. Then what is phasor method for? Phasor method is for visualization. You understand what I am saying? Phasor method, or this whole topic is about visualization. That is, it is imagining, right? So this will allow you to calculate things like time and all that fairly simply, right? Very, very easy, right? Okay, let's take a couple of more questions like this. Okay, so let's take one where you would rotate clockwise. So suppose x is equal to, let's say, 4 cos, let's say, pi by 3 minus pi t. Okay, x equal to 4 cos pi by 3 minus pi t. This is also simple harmonic motion, right? This is also simple harmonic motion, right? And if you just pick it up directly like this, if you pick it up directly like this, you see what happens. Listen to this carefully. There are multiple ways to do this. Be cautious. Listen to every word carefully. If you would compare it with x equal to a cos omega t plus phi 0, right? That's it. So, do you realize that here it looks like omega is minus pi, yes or no? Do you realize that it looks like omega is minus pi, yes or no? Right? This is what makes this phasor or this particle turn clockwise. This is what makes this phasor or particle turn clockwise instead of anti-clockwise here, because omega is negative. Because omega is negative, that's why it's turning clockwise. You will say that, right? There is another way to see this. Have a look at this. Suppose I draw initial position. Initial means phi 0 how much? Everyone realizes pi by 3, correct? 60 degree. So initially the phasor would be here. And how much? At 60 degree or pi by 3 with the positive x-axis. Clear? This amplitude being 4. Alright? Now, think about it. As you increase t, look at this whole angle, phase angle, pi by 3 minus pi t. This is your phase angle here. If I will start putting bigger values of t, I am subtracting more, correct? That means as t will increase, phi will decrease. Do you agree with this? As t will increase, phi will decrease. Sorry Raj, omega is negative but time period will not be negative. That's what I am going to talk about now. Okay, of course, time period can never be negative. Is this clear? Is this clear to you, everyone? So what is that telling you? Listen to this carefully. What is that telling you? It's telling you that as time will pass, this angle which was pi by 3 initially, this angle which was pi by 3 initially will decrease. So if the angle is to decrease, what do you think? How should it turn? Should it turn anti-clockwise or clockwise? Think about it. If this angle is to decrease, should it turn clockwise or anti-clockwise? Dia is only lagging for you. There's some problem on your side. Okay, very good. Clockwise. I hope that makes sense to everyone. Right? So what this means is whenever you are getting this kind of behavior, what it really means is that angular velocity of this phasor, listen to this carefully, angular velocity of this phasor is in opposite direction. That is, instead of being anti-clockwise, which is positive, this is clockwise, which is negative. Right? Then what about time period? Raj asked about time period. Don't forget, time period is 2 pi by omega, where omega is angular speed or angular frequency. Okay, both formulas are valid. This is actually angular velocity. I repeat, this is angular velocity. Do you understand what I am saying? Do you realize what I am saying? This is actually angular velocity because it's also indicating direction. Hopefully you remember the difference between angular speed and angular velocity, right? Okay, so angular speed, if someone would ask you what's the angular speed? Someone would ask you what's the angular speed? Would it be minus pi? No. Angular speed would be pi. Is that clear? Is that clear or not clear? Okay, so angular frequency is also the same. Angular frequency is pi as angular speed is, right? So this will be 2 seconds. Clear everyone? So what's the difference? What is the difference between some equation like this and an equation like this? Nothing, isn't it? Just one point here, the rotation direction, clockwise or anti-clockwise. Understood? Just the rotation direction. Fine. Everyone got that? Okay. So, can phasors rotate anti-clockwise and clockwise? Any of them? Yes. They can. Listen to this carefully now. They can rotate anti-clockwise or clockwise. There is no problem with that. Okay. But now comes the main thing. But what happens is later on, to avoid confusions when we use phasor, right? This same equation can be written, can be modified. This same equation can be modified and it can be made to turn anti-clockwise. I repeat. If your math is good enough, this same equation can be changed a little bit and we can make this turn anti-clockwise. So then there is always going to be confusion. If you are given some equation, will it turn clockwise or will it turn anti-clockwise? Right? It's always possible. Remember, even in this question, I can make it turn clockwise if I want. Okay? You just need to do a bit of maths. That's it. So, we will remember this, everyone. We will remember what I am writing over here. Okay, by default, that is generally, unless otherwise mentioned. Unless otherwise mentioned, phasors turn anti-clockwise. Simple idea. Unless otherwise mentioned, the phasors will turn anti-clockwise. Clear? If the question does not specifically say that phasors are turning clockwise, then you don't worry about clockwise at all. We will make them turn anti-clockwise also. Because pi by 4 is not given in the question, Gracie. This is pi by 3. Why are you so insistent upon pi by 4? In the question, pi by 3 is given. Why should I take pi by 4? Everyone, this sentence clear? Is this sentence clear? We will by default take the phasors to turn anti-clockwise. Now then there arises a problem. What about this? Okay, you might have a question. Well, I explained that it looks like this phasor turns clockwise. Now, I am saying that we are going to make it turn anti-clockwise. That sounds crazy, I know. let's see a bit of maths. If you look at this equation, here we have cos of something, cos theta. Now there is a very simple property in mathematics. That's this. Math students, I'm sure you know this. Okay? If you don't know, you are in deep trouble. Cos minus theta is cos theta. Right? Cos of minus theta is cos theta. Let's apply that here. So this very equation can be written like this. Yes or no. Clear or not clear? Using this property. Sure, understood there? This is minus theta, and if I flip the signs, okay, this I make positive and this I make negative, then it will become theta. So like that the sign has changed. Now have a look at this. Have a look at this. There is no difference between these two, mind well. That is, x equal to this and x equal to this are same equations because of this property. Now look at this. What is omega? Look at this. What is omega? Pi radian per second. What is phi 0? What is phi 0? What is phi 0? Everyone. It's not pi by 3. It's minus pi by 3. Correct. Phi 0 is now minus pi by 3. So, if I try to draw a circle now, okay, indicating the phasor or indicating UCM here, let's see what happens. Where does it start from? Minus pi by 3. Minus pi by 3. Negative angle clockwise. Remember, anti-clockwise positive angle. Is it clear somewhere over here? I am not drawing this exactly. Okay? I am not measuring it. You cannot draw exact angles just like using a pen. It's impossible. So this is minus pi by 3. And now how will it turn? Look at omega. How will it turn? Is it going to turn clockwise or anti-clockwise? How will it turn? Clockwise or anti-clockwise? Anti-clockwise. Very good. So this point P here is going to turn anti-clockwise like this. So the question might arise in your mind. Which of these diagrams is correct? They look completely different. Here we were saying that it starts at pi by 3, initial phase is pi by 3 and then turns this way. And now over here we are saying that this turns this way from here. So which one is right? Okay, which one is right? The truth is both are same. They mean the same thing. They indicate the same SHM. They represent the same SHM. Clear? Because of this mathematical property. So this is what I was telling you. Now read this sentence. What? Generally, we take the phasor to turn anti-clockwise. Okay? So is this wrong? No. No, it's correct. But normally we don't show it like that. We show it like this. Understood the whole thing? So is this a property worth remembering, everyone? Definitely. Okay, math students, I'm sure you already know this property. Biology students, remember it. You know why this is happening? Let me just give you a little bit of idea. Hopefully you will understand. It is because if you compare this point with this point, do you realize that the point over there is here? This one? So their x coordinates are same. You get what I am saying? They represent the same point as component on x axis. Correct or not? Their x coordinates are same. Yes or no? Yes or no? Okay, sign આવે તો શું કરવાનું? That's the question. Okay, we will talk about that also. Don't worry. All right. So there is no difference, like I said, but this is the convention. This is what normally we do. So you be careful whenever you get cos and you get something like this, you have to change it using this relation like this. Okay? Fine. Okay, now moving over to what happens if it is sine, right? So let's try something like that. Suppose someone gives you y equal, let's say 5 sine 3, no, 5 sine pi by 2 minus 3t. This. Okay, and this is in centimeters. So if you try to draw it in a clockwise manner, this is very simple, right? I am not doing it. I repeat, I am not doing the clockwise portion because there you don't have to do anything. Just use the simple idea, like 50 pi by 2 omega is minus 3 and all that. Okay. Let me turn it to anti-clockwise, right? That's what I am going to show you. Now the problem here is, listen to this carefully. Sine does not follow same property. There is another property of sine that might be useful for us sometimes. So let me write it. Okay, it's not useful here, but it will be useful in some other equation. Okay, possible. The property of sine is this. Sine minus theta is not sine theta, but is minus sine theta. Right? This is opposite behavior compared to cos. Okay, if you try to use it here, we run into another problem. Listen to this. What's the problem? Okay, this part is indicating the problem. Don't try to write it in your notebook. Okay, so if I do that here, what will happen? I will get minus 5 sine 3t minus pi by 2. Did you understand this step using this property? Yes or no? If angle is made negative, we get minus 5. What's the problem with this? The problem is this is nonsense. Can amplitude be negative? Think about what is meaning of amplitude. Amplitude means the maximum distance between what? Between mean position and extreme position. That is basically the distance, right? The maximum displacement. Clear? How can that distance be negative? It's impossible. Okay? So, another problem is if you try to draw this as radius. Have you ever seen a circle whose radius is minus 5? Have you ever seen a circle with radius minus 5? Is it possible to draw such a circle? So, understood what's wrong with this? Everyone gets it? What's wrong with this is clear? Okay, so what to do then? Well, so we can use some other property of sine. Okay, we can use some other property of sine. And that is sine of theta is equal to sine pi minus theta. Pi means 180. Right? Sine of theta is sine pi minus theta. So take this whole thing as theta. Then this will become sine pi minus theta. Did you understand this? Raise your hand. I use this property. Pi minus theta. What's theta? This whole thing is theta. Okay? So no change. So y is equal to 5 sine pi minus pi by 2 plus 3t. And you see the problem is solved. Clear? Okay, the problem is solved. Understood or not? Pi minus pi by 2 is pi by 2, right? So how to draw this? Circle, how much radius? 5 centimeter radius. Correct? Amplitude. What is initial phase? What is initial phase? What is initial phase? Pi by 2, of course. Correct. So it will start from which point? With 1, 2, 3 or 4. It will start from which point? 1, 2, 3 or 4. It will start from which point? 1, 2, 3 or 4. Very good. 2. Well done. Well done everyone. So here. Alright, it will start from here. So this is the phasor starting from here. Will it turn clockwise or anti-clockwise? Will it turn clockwise or anti-clockwise? Anti-clockwise, of course. આટલી મહેનત કેના માટે કરી હતી? Anti-clockwise માટે કરી ને આટલી મહેનત. I hope you see what I am doing here, right? So this will turn anti-clockwise like this. This is initial phase, phi 0 equal to this one, correct? Clear? So now what is the initial phase? What is the initial phase? What's the initial phase? Minus pi by 2. So if I will draw this, first of all it will be SHM on x-axis, right? And initial phase is minus pi by 2. It will start from here. So that's your phasor. Understood? Okay? And then it will turn anti-clockwise. This will be 5 centimeters. Absolutely clear? Absolutely clear or not? Okay. So this is what you will use to convert sine to cos. Now let's go reverse. Okay? That's the last thing we are going to talk about today. What if you go reverse? That is, suppose it's given like this. Right? So don't jump to saying that phi 0 is minus pi by 2. No, it's not. It's not valid because this is y and this is cos. It's a mismatch. Okay? We have to correct for this mismatch. Understood? Right? So, okay. Let's, for making it slightly tough, let's make it pi by 3. I've changed this. For making it a little more tough, we're making it pi by 3. Not that it's going to become very tough though. Okay. So, if it's like this, we will use again a property of cos. It's that cos theta can be written as sine pi by 2 minus theta. Are you aware of this? This is clear so far? This you have learned in 10th standard. Correct? 90 degree minus theta. But this is not enough because if you do this, you will end up with another problem. The problem is here, this is positive, but if you put minus theta, they will become negative. So, we will use one more property that we have learned, and that's this. Do you remember this one? So, if you use that, if you use this over here, this will become sine pi by 2 plus theta. Of course, math students are aware of this formula directly. Right? Cos theta is sine pi by 2 plus theta. So if we use that property, okay, this is of no importance for us right now. I was just explaining using this and this we get this. So let's apply it here. We are going to apply cos theta equal to sine pi by 2 plus theta. This is the main thing for us. Use it here. So 4 centimeter. Instead of cos theta, sine, add pi by 2, 4 pi t and minus pi by 3. Did you understand this? Everyone? This whole thing is theta. Yes or no? Okay. So let's simplify and we'll get it done. 4 pi t as it is. Pi by 2 minus pi by 3. See, quick way to do it. Pi by 2 90 degree. Pi by 3 60 degrees. 90 minus 60 is 30 degrees. 30 degrees is pi by 6. Is this okay or not? Everyone, is it clear? Or you can take LCM, of course, and get it done. Right? So now we have it, right? We have initial phase. Now you can draw it yourself, I am sure. Okay? Time period will be 2 seconds. Omega is 4 pi. Turns anti-clockwise. So this is how you manipulate these equations using these kind of relations. Okay, this one, right? And you draw these things. Okay, today you are definitely going to get some homework that I'll send you a message later. Alright, goodbye.